So, Connor, we left off on example 10. The toughest that you can get. Cliff at an angle. Did I say angle? So the first thing I still did was I broke it up into components. That much I could do. Pause for 1 second. We went to our T-chart. We listed horizontal acceleration was 0, horizontal velocity, vertical acceleration negative 9.8, vertical initial velocity. We noticed they gave us the 60 vertical. We said, okay, I'm going to solve this vertically, and this is where we had to pull out the quadratic formula. Well, I lied. If you are good at the quadratic formula, it's probably the best way to do it, but I will show you in another example a way to do this bypassing the quadratic formula. The only problem is there's a mini curveball that you absolutely, Drake, have to remember. Okay? We're good?
Yeah.
Boy, what'd you do to that lesson? It's crumpled. Okay, whatever. So I said pause here. And I also said you're capable of doing those questions from the great big ultimate review. I'll give you the ultimate review later, Robbie. I'm going to, because after today, you'll be able to technically do every question, although some of them I haven't covered. What else could I ask? I said B, find time to top on the next page. I couldn't fit this all on one page. Find time to what? Okay, vertical. Since most of us have turned the page, I'm going to relist my data. So we had AY was negative 9.8. VY initial, was it 25, I think? Let me scroll back. Yep. Top. Can I find a time from that? I think so. It's also why I didn't leave you that much room to solve this one. I think we can use good old VF equals VI plus AT, getting the T by itself. I think we end up with what? Rebecca, you want to get the T by itself for me in VF equals VI plus AT?
VF minus VI over.
By the way, time, positive or negative? Rebecca, time, positive or negative? It's a scalar. So I should get a positive. I started to get a little worried when I went 0 minus 25 because the top was negative. And then, oh, no, the acceleration is negative 2. Oh, thank you, nature. You took care of yourself for me. Appreciate that. I was a little worried the universe was going to let me down. Time to top, 2.551. I'll go 2.55. Now, remember, we did last lesson finish off by finding total time of flight. Total time of flight was 6.88 seconds. You know what? I should have carried some extra sig figs, and I forgot because we're going to use that. But total time of flight was that. So if the time to top is 2.55 and the total time of flight is 6.88, how long does it take to get from the top to the ground? How could I figure that out? Yeah, so I could subtract. That's now doable. Okay. What else could we handle? Oh, find the range. Range is horizontal, so I'm going to remind myself horizontally AX is 0, VX was 43.301. Time, well, I didn't have that. Yeah, I did. Did anybody write more sig figs than the 6.88 on their calculator? Okay, I'm really going to quickly use my solver on my graphing calculator. Polynomial root finder, degree is 2, A is 4.9. This is the quadratic that we solved. Negative 25, negative 60. Solve. Sorry for those of you. Okay, 6.8814. So I'm going to make a little note here. T equals 6.8814. 5 sig figs should give me enough breathing room so that 3 sig figs is accurate. Okay, so I'm going to use T equals 6.8814. And I want to find the range. How? D equals VIT. Why did I stop writing there? A is 0, so you can write plus a half AT squared and cross it out. Or if you're clever, Connor, you could have maybe, if you were clever, Connor, have noticed that you could have crossed it off. 43.301, 6.8814. Is that okay, Drake? And horizontal goes into horizontal equation. You'll notice I double-checked. Don't put Vy into here. Don't put the slanty into here. This is one of my rants. Horizontals into horizontal, vertical into vertical. Directions matter. 43.301 times 6.8814. 297.9. You know what? I think to 3 sig figs, 298 meters. 3 football fields. That's a pretty good launch. Is that okay? Duncan, what's D you want me to find? This is probably about as tough as it'll get. Finding a velocity. Okay? Can you imagine the projectile? I think, don't write this down. I think the projectile as a path does that. In other words, I think it hits the ground at an angle downwards. Impact velocity. Ty, you okay with that? So I'm going to draw that nice and big. This you can draw. I'm going to imagine the impact velocity looks like that. That's V, and I'll call it, how about imp for impact? It may be steeper, Ty. I don't know. I really don't care. I do know it's angling slanty downwards. Drake, did I say slanty? What's this a job for? I'm looking for a word that begins with the letter C. Components, right? As soon as I get slanty. So I'm going to do this, Drake. Now that I've drawn that, I'm going to say, you know what? That can be Vx and Vy final. Why didn't I put a final on the Vx? No, why didn't I bother putting a final on the Vx? Never change it. Oh, did you say constant? Yeah. I thought you said positive. I'm sorry. Yes. What was Vx? I scrolled down. 40, what? Okay. It seems to me, Drake, if I can find Vy final, how fast it's traveling vertically when it hits the ground, not 0, that's after it hits the ground. If I can find how fast it's traveling vertically, then can't I go Pythagoras, because I'm adding them together tip to tail, and can't I find theta? And that'll give me the impact velocity, because velocity has both magnitude and direction. Okay, so even though this is saying find the impact velocity, I'm going to spend a lot of time finding Vy final. What was Vy initial? Was it 25? And A was negative 9.8. And T was 6.8814. Hey, Rebecca, is there an equation that I can use that'll get yeah, good old VF equals VI plus, oh, and the VF is by itself already, kind of cool. So how fast it hits the ground vertically is going to be equal to the initial velocity plus AT. But remember, vertical, 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 vertical. I'm going to get positive 25 plus negative 9.8 times 6.8814. By the way, when it hits the ground, is it traveling up or down? Am I hoping to get a negative or a positive Vy? I hope I do. If I do, I won't freak out. I'll smile and say, woohoo! 25 plus negative 9.8 times 6.8814. Whew. Negative 42.43. Did I round off wrong? 44. Negative 42.438. And that's what I'm going to put on the triangle over here. 42.438. Mr. Duke, what happened to the negative? Oh, the negative is in that arrow pointing down. That's the negative. And now we can go Pythagoras. By the way, do you notice these two velocities are almost the same? This is almost an isosceles triangle. Theta is going to be really close to 45 degrees. If I get like 31 degrees, I've messed up. Yeah?
What happens if you do put in the negative?
It turns out I won't take marks off, and it turns out you'll probably get away with it because when you square a negative, you'll lose it if you type it into your calculator right. But, meh, I'm lazy. Why bother? So Pythagoras is going to be 43.301 squared plus 42.438 squared, whoop, wrong button, square root. The magnitude looks like it's 60.6. And since it's my final answer, I'll now go to 2 sig figs. So V impact equals 60.6 meters per second at always where the vector starts from, which is right there. This 42.438, or Vy final, opposite adjacent to hypotenuse. Opposite, what about the 43.301, Vx? Which cool. Tan of mystery angle theta equals opposite 42.438 over 43.301. I'm hoping to get an angle really close to 45, do I? 44.4. .4 degrees. What of what? North of south? Well, if you said south of east, I wouldn't take marks off, but I would think bad thoughts about you. Because up is not north. Down is not south. I know on a piece of paper we make them that way because we have to somehow change a three-dimensional world into a flat piece of paper. But for a projectile, because we're looking at it from the side, I would argue up's not north and down's not south. I would give you credit. How do we say this? We actually refer to this as below the horizontal. That's a fancy way of saying if you draw a horizontal line and then you drop down 44 degrees, you'll end up on the resultant. See it? In fact, sometimes you'll see, I'll come back to that, this 30 degrees here referred to as above the horizontal. Is that okay? I mean, I'm going to say I like that question. I don't know if I'm saying I like that question, I like that question, I like that question. What I am saying is, hey, that puts everything together of this whole unit in one question. Do we do a little vector math? Do we add some stuff tip to tail? Do we bring a little components in? Do we do some projectile math? Okay. Yeah.
So if I were to draw the angle, instead of going across and down, just down and across.
Yeah.
How would I word that instead of below the horizontal? Because it's a different answer.
Yeah, you would get the complement, so you would get 45.6 degrees.
Yeah, approximately.
Yeah, thanks. It's a good question because no one writes it that way. You would probably say something like off of the vertical.
Okay.
I mean, you could say to the right of vertical if your picture was pointing to the right.
Yeah.
Number 11. Number 11 is basically the same as the one we just did. Cliff, 10A, said find the flight time. We dawdled around a little bit, but then C said find the range. So we can do number 11 the exact same way. Components, quadratic formula, but I'll show you the non-quadratic method for number 11, and you can pick whether you want to use method question 10 or method question 11. No matter what, though, we still start with components. Is there a slanty? This is a job for components. I'm looking for a word that begins with letter C and rhymes with components. And I'm going to just make the triangle a bit bigger so that it's not so microscopic. So this angle here is 20 degrees. This is 35. That's Vx. That's Vy initial. Opposite, hypotenuse, adjacent. Let's do horizontal first. Which trig function? Cosine of 20 degrees equals Vx over 35. So Vx is going to be, how would I get the Vx by itself? What do I do with that 35? So I'm just going to go straight to that without showing that step. On a test, I'd probably write out one more line. 32.889. Which trig function is going to be that one? Sine? Sine of 20 degrees equals Vy over 35. Vy, I think you'll times by 35 again. So you'll end up with 35 sine 20. 11.971. Heck, I'll go 11.9707 because there's a 0. That's a nice place to stop. Is that right? People agree with me, or am I wrong? I'm good? Now what? What do they want me to find? Okay, how am I going to find time? How am I going to do that? Before I even do that, do a t-chart, right? Let's set it up right. So horizontal, vertical, ax equals 0, ay equals negative 9.8. That will always be the case unless we're on a different planet. Vx equals 32.889. Vy initial equals 11.9707. How many things do I have in the left table? 2. How many on the right? 2. Not enough. I can't solve this. Or can I? What else do I know? Which kind of a distance? I gotta be fussy, not a distance. Displacement. So what am I gonna write? D equals negative 20. Okay? And now I could, if I wanted to, find t using the quadratic formula. And if you're good at that, or if you have a quadratic solver, probably your best option. But I promised you a method. I promised you a method to find something else. And there is. I can also find how hard it hits the ground at vertically. There is an equation that has A, V initial, D, and V final in it. Which equation? Squared. Say it again, Duncan. VF. And I conveniently have the VF by itself. I'll have to square root. In fact, you know what? There. So, Vy final is going to be the square root of 11.9707 squared plus 2 negative 9.8, and I have to remember to put the negative in front of the 20 because it's a displacement. Have we used the quadratic formula yet? Nope. Okay. Oh, you know what? I'll use my answer button. Squared plus 2 times negative 9.8 times negative 20. That's not VF, that's VF squared. Now what? Square root. And I get Vy final equals 23.1365. Which is wrong. Why must that be wrong? Huh? Okay, if you're going to use this method, you will have to remember to include the negative after. And it comes out of actual math. What's the square root of 9? 3 or negative 3, right? You guys learned, I think, last year, technically it's plus or minus 3. What's the square root of VF squared? Technically plus or minus VF. And in this case, Nevada, I definitely want the negative 1. It's going down. So I have to add that. That's the tricky part with this method. That's the part a lot of kids forget with this method. They forget to add the negative. Now, why is this so nice? What am I still trying to find? Hey, find an equation with those in it. Find the equation with time and no d. And it's not quadratic. And it's not quadratic. I can go now for part A, t equals Vy final minus Vy initial over A. Make sure it's vertical, make sure it's vertical, make sure it's vertical. It's going to be negative 23.1365 minus 11.9707, all divided by negative 9.8. Bracket. Negative, answer button, because that is negative 23.1365, but even more sig figs, minus 11.9707 divided by negative 9.8. And I get a time of flight of 3.58236. You know what? I'll go 3.5824 seconds. Connor, did I round off properly? Oh, small mercies. Anybody here have the quadratic solver? If you want to really quickly, you could try solving the following quadratic. Negative 20 equals 11.9707 t minus 4.9 t squared. Make it equal to 0, 4.9 t squared minus 11.9707 t minus 20 equals 0. If you want to plug 4.9 in for A, negative 11.9707 in for B, negative 20, please tell me, do we also get 3.5824? I bet you we'll get to 5 sig figs, and then it might be, so my answer was 3.582367. Probably we all match to about there. But I've rounded off along the way, and the quadratic didn't. Yeah, so you know what, we're good to like 6 sig figs. Okay. My point is, you absolutely, Ty, have to be able to find time off of a cliff launched at an angle. You can find it by finding Vy final and using Vy final to find time. No quadratic formula required. Or you can find it by using the quadratic equation. So I'll make a little note here. Use quadratic formula, if you want to use that method. Both are equally valid. Both have pros and cons. Which one do you use, Mr. Duick? It completely depends which calculator I have handy. If I happen to have a calculator that's got a quadratic solver, I'll use the quadratic formula. If I have just a generic scientific calculator, I can do pretty much all of this without writing anything down, just keeping track of the numbers and get there pretty quick too. Is that okay? Brennan, what did B want me to find? Oh, that's dx. That's going to be vxt. What was vx? 32 times, what was t? Oh, we just figured it out. 3.5824 seconds, but I'm going to use my answer button. I'm going to go 32.889 times, haha, answer button. And I get a range of 118 meters, 117.8, blah, blah, blah. I'll go 3 sig figs in my final answer. 118 meters. By the way, up here, my final answer for time should have been 3.58 seconds to 3 sig figs. That's the one I should have put the box around, but I'll keep the extra digits for later. I like this question, I like this question, I like this question. This is a nice question. Okay. I'll even be more blatant. There's going to be a projectile at an angle off a cliff on your test. Okay? Right now, just with that, you should be able to handle number 1, number 2, number 3. You're probably going to need to do these on a separate piece of paper unless you write incredibly small. Number 4 is a thinking thought experiment. Put a star next to number 5. I'm going to assign it, but actually it's part of this upcoming lesson. I don't know if I'll get that far. If you don't get it on your own, I mean, in theory, you should be able to figure it out, but I recognize a lot of you won't. I will cover it next class, okay? I'm going to skip 6 for projectile. Find the... Seven is asking you to find a final velocity and impact velocity. We're going to add stuff together tip to tail. Skip 8. 9 is good. 10 is good. 11 is good. 13 is good. I'm not going to turn you loose just yet. I want to continue a bit with the next lesson, okay? So we're going to start lesson 6. I'll go for a few minutes and then I'll hit pause. But ideally, lesson 6 should be lots and lots and lots of review. And then the second half of lesson 6 is nothing but nasty, weird questions. So when we launch an object into the air, we call it a projectile. Projectiles travel in a parabolic trajectory. They follow a parabola. It's one of the reasons you look at the parabola so much in high school math. It shows up all over in nature. And we break each projectile's velocity into horizontal and vertical components. Okay. It says break the following velocity vector into its horizontal and vertical components. Vx, Vy, right? Hey, that 24, opposite, adjacent, or hypotenuse? Vy. Vx. Okay. If you're... No, never mind. I was going to give you a dumb shortcut, but it's not a consistent one. I'll give it to you next unit where it is consistent. Which trig function for Vy? See it? O and H. Drake, as a shortcut, can I just go straight to going Vy is going to be 24 times the sine of 36 when you do the opposite over hypotenuse and then multiply 36 over? And Vx is going to be which trig function, folks? Of course it is. So it's going to end up being 24 cos 36. 24 cos 36, 19.4 They didn't ask me to do anything with this, so I'll just stop at 3 sig figs. 19.4 meters per second. And 14.1 meters per second. Okay. Probably that'll be what I consider a fairly low ball question on the test, but I will probably give you a velocity vector and say, hey, tell me the components. All right? So hopefully that's as close as you'll get to like free-ish marks. Gotta do some work still. Summary. Horizontal motion, key idea, Vx is constant, which means Ax is 0, which means d equals Vit plus a half At squared becomes Vx times t. This means also, if you know the time of flight, you can find the range. Or the other nice thing, up until now, I've always given you the height of the cliff. If I give you the range, then you don't need a quadratic formula to find time. It's just going to be the range divided by Vx. Horizontal is so much easier to solve, the quadratic doesn't show up because no A. Vertically, Vy changes. What's constant is the vertical acceleration at negative 9.8 meters per second squared. So dy does equal Vy initial t plus a half. You can even, if you want to, put a y underneath the a squared, t squared. Other handy things, at the top of its arc, Vy is 0 for a split second. Does this mean that total velocity is 0? No, it's still traveling sideways. Also, if we start on the ground and end on the ground, Vy initial equals negative Vy final. That can be handy. Last, if you're beginning from a vertical height, the ground is below you. And this means your final displacement will be negative. Your vertical displacement will be negative. Mr. Dueck? What, Liam? You said that projectiles travel in a parabola, in a parabolic path. Well, yeah. But I've seen some projectiles that kind of seem to wobble. Put your pencils down, throw, look up. I've just done a question from a cliff at an angle. Do you guys feel okay with those? So I'm going to skip example 1. Oh, no, I'm not, because I need to talk about example 1, part C. What time is it, Mr. Duick? Okay. Here we go. Dulp. Cliff. There's the initial velocity of 36 with an angle of 64 degrees. There's Vy initial. Oh, and they told me that this was 45 meters. I've realized now I need to retype, leave anywhere near, well, maybe I left enough room. Yeah, it's going to be tight. Okay. Is this slanty components? That's why I did that. I think we're going to find that Vx is adjacent hypotenuse. I think it's going to end up being 36 cos 64. You know what? Rather than round off, I'll just keep writing that whenever I need Vx. 36 cos 64. And Vy initial is going to be 36 sine 64. I mean, okay, some of you are looking at me like deer in the headlights. We can crunch this. 36 cos 64, 15.781. So you could go 15.781. And then you could go 32.357. And that's fine. Although it's almost as much work just to type that as it is to type that, and that's exact. It's up to you. T-table. Right here. Horizontal, vertical. I really didn't leave much room here. Well, I know AX is 0. I know AY is negative 9.8. I know VX is 36 cos 64, 15.781. And I know VY initial is 36 sine 64, or 32.357, blah, blah, blah. I know that D vertical equals negative 45. Is that okay? How would you find time vertically? And now you could either, Nick, find Vy final and then use that to find time, or you could use the quadratic formula. In the interest of time, no pun intended, I'm just going to make a little note here. I'm going to say either find Vy final or use quad form. And Vy final is a subscript. I think I can do that here, Mr. Duick. Oh, there it is. Boom. I'm not actually going to solve part A, because you guys are kind of getting loogie and I want to get a little further here. What I want to talk about is part C. Part C. What does part C want me to find? Which might look like that if it's on its way up, or it might look like that if it's on its way down. Okay? Which one? I don't know yet. I do know, don't write this down. Whether it's on its way down or on its way up, I'm going to break it up into, because it's slanty, Vx and Vy at 2.4 seconds, because that's what's changing. Don't write that down. All I'm saying is, I think I'm going to go, so don't write this picture down. See a bunch of you doing that. Don't, because this is wrong. Okay? What I'm going to do over here is I'm going to make a note. I need to find Vy when t equals 2.4 and a equals negative 9.8. And what was Vy initial? Oh, heck. 36 sine 64. If Vy at 2.4 seconds is negative, that tells me that the projectile is on the way down. If Vy is positive, and I'll draw this, right? If Vy is positive, that tells me the projectile is still on the way, and I'll draw that. That's why I said don't start drawing yet. Now you could find out. We can go straight V final equals V initial plus AT. We can go straight V final equals V initial, 36 sine 64, close bracket, plus negative 9.8. And the reason I can go straight to this is they gave me the time, so no need to pull out a quadratic formula or anything like that. And I get, at 2.4 seconds, the vertical component is that. James, did I get a positive or a negative answer? Is the projectile on its way up or on its way down? James, did I get a positive or a negative answer? Is the projectile on its way up or on its way down? Are you positive? Because, yeah, okay. So, you know what? As a picture, now I'll dob. There's the velocity that they want me to find at 2.4 seconds. And it's made up of those two. Where this one is, I forgot to write the answer down, Mr. Dewick, 8.8366. 8.8366. 8.8366. And this one, you could either write 36 cos 64, or heck, let's go 15.781, because you guys want numbers. What did I say, 15.781? There we go. Now what? How can I find the resultant Pythagoras and trig? Pythagoras says that number squared plus 15.781 squared, square root, and I get 18.1 meters per second. V equals 18.1 meters per second. Now that's the speed at, and I guess the angle is going to be this one, and this one is going to be above the horizontal as opposed to below the horizontal. Opposite, adjacent, shift tan of 8.8366 divided by 15.781. 29 degrees above the horizon, or the horizontal. That's a much tougher question. Okay. Pick up with lesson 6. Yeah, am I wrong? Okay.
If you were doing it, but UII being 36 sine 64, how would you do that?
Oh, good qual. Yeah. Fair enough. Well, you mean if you're doing that for Vx? Because Vy we had stored on our calculator initially. Okay, sorry. Let me bring this back. Because that's how I typed it for Vy, 36 sine 64. I had to close the bracket off on mine. You have a graphing calculator too, yeah? TI? Plus, negative, blah, 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 blah. That's what gave me this number here. Now I'll use my answer button for that number. Okay? So it's going to be answer button squared plus, if you wanted to, you could go bracket 36 cos 64, close off the cosine, close off the bracket, squared. That's how you would do it. Or you could just go to 5 sig figs. I think in hindsight, I shouldn't have showed you the trick of trying to keep everything. But there you go. Okay?
Easy, right?
Your homework is last day's stuff, lesson 5 stuff. Let me hit pause here.